Okay, some key points from the lesson. The big things I want you to remember is the differences between integer programs and linear programs, or mixed integer linear programs and linear programs. The big takeaway, whenever I have an integer variable, whether it's binary or just straight integer, they're harder to solve. And this is because the solution space expands. Now the number of potential solutions actually is lower than if I have continuous variables, but remember, for linear programming, we found the result, if I have a convex feasible region, that the solutions will only be in those corners. So for Banner chemical case, we only had 5 potential solutions as a linear program. For an IP, there was a lot more. So ironically, the solution space increases when I reduce the number of variables that I can choose from, going to integer from a continuous variable. Now the formulations become more important. For linear programs, if you have a mathematically correct formulation, that's fine. It's good, it'll work. For integer programs, a correct formulation is necessary, but it's not sufficient to guarantee that you'll actually solve the problem. These IPs in real life can take days, weeks to solve, and you can strengthen your formulation in different ways that it's still correct, but it's taking advantage of certain things. So for example, when we use that linking constraint with a big M, how I set that M and how I set those constraints that link have a big impact. And you can do some mathematical techniques or tricks in the formulation to make that a tighter constraint. It goes beyond the level I wanted to discuss in this course, but just be cognizant that just because you formulate the integer program correctly mathematically, there are probably better ways to do it to make sure the solvability occurs. And that's, again, beyond the scope of what we're looking for in this course. Typically, what you'll do for this, to solve an IP, you'll solve multiple linear programs, and you're essentially relaxing the integrality of these different variables. And so you'll solve it, a linear program, with it being high, with it being low. And you keep doing these. It's called branching and bounding. And so the point here is, this is why it's so much harder to solve an IP than an LP. You can't just round the LP solution. It might not be feasible, and if it is feasible, it might not be optimal. This is what we saw in the Banner chemical case. And when using integer variables, you should always just try to solve the relaxed solution first and see if that's sufficient. Always take a look at that. Then we introduce binary variables, and this is the real meat of this lesson. They're very powerful, and you can use these for including logical conditions into your model. So if-then conditions, these link continuous variables to binary variables, and you have this sum of xij minus big M number m times y sub j less than or equal to 0, and this ties together the continuous variables, the xij's, with the fixed variable yj, the binary variable. You have either or conditions, which ensures a minimum level if it is used at all. And so I have my linking constraint, and I add in this other lower limit constraint with the sum of xij's minus this L sub j, the lower limit, times yj has to be greater than or equal to 0. And again, remember, the L must be less than the M value. Your lower limit can't exceed your maximum capacity. You'll have an infeasibility, and you won't be able to solve that problem. Okay, the last one we did was select from, and this is where you pick the best X of Y choices, either a min or a max. In this case, in our model, we choose a less than, so you have the linking constraints, and then you have this added constraint, which is just the sum of the binary variables must be less than or equal to n. Other cases you might have it set up, you have to have at least a certain number of things open. So these 3 types of variables are so powerful, and you'll see these all the time, especially when we talk about network design in later courses. So the power of the binary variables is that you're able to include all these different conditions in the same framework as a linear program, and these are what's known as mixed integer linear programs. All right, we covered a lot. You should practice, practice, practice. I didn't go over specific software tools on purpose because there are many different options you can select from. Look at the recitations, pick the tool you want to use, and follow that recitation. Hopefully you can solve those problems. Use the quick questions, try the practice problems, see how they work.